Today I want to show you how to change your quadratic equation from standard form into factored form and into vertex form. And then from there, from each one of those forms, how to find the x-intercepts or the roots or the solutions they're called. Okay, so we're going to start with standard form, and I'm going to go ahead and change into factored form to start. So factored form, we use the big X, and the B goes on the bottom, and the C goes on the top. 3. So it multiplies to 3 and adds to 4, 3 and 1. I use these inside or the lateral numbers as my roots. So I'm going to write my factored form equation as y is equal to x plus 3 times x minus 1. And we're in factored form. All right, now we're going to change this equation into vertex form. So to get into vertex form, what we do is we get rid of our c values. So y is equal to x squared plus 4x plus 3. We're going to subtract the constant to the other side. So y minus 3 is equal to x squared plus 4x plus something. So we're adding something in here, and then we're going to add something to the other side of the equal sign as well. I use the big X, so I use the b value is 4, and I need to split the b value evenly so I get perfect square factors. So 2 plus 2 gives me 4. Then I multiply those together to give me the c value. All right, and that's what goes into my perfect square trinomial. So I'm going to add 4. If I add 4 to one side, I'm going to add it to the other. Next, we go ahead and simplify. So y plus 1 is equal to, what does x squared plus 4 factor out to? So x, what times what? You can see it in the big X. This is x plus 2 times x plus 2. Or you can write that in one step as x plus 2 squared. We're going to subtract 1. So we get y is equal to x plus 2 squared minus 1. Bonus, you get to see the vertex. Where's the vertex? The vertex is at -2, 1, -1. And is this graph concave up or concave down? And it's concave up because the a value is greater than 0. It's positive. Okay, so the next thing we're going to do is take these different forms and figure out our x-intercepts. So below here tells us how to solve each one of these, from each one of these forms, how to solve for the x-intercepts. So let's start with factored form. And factored form is nice because all you do is use zero product property. So in a root, the y is always 0, so we're going to replace that with a 0. And we're going to write this as x plus 3 times x minus 1. So one of these factors has to equal 0 in order to multiply to give me 0. So I split them. X plus 3 is equal to 0. And when x minus 1 equals 0, then I'm going to get a result of 0. So x can equal -3, or x can equal 1. Those are my, as ordered pairs, it's -3, 0 and 1, 0. Okay, let's go ahead and tackle the quadratic formula. So I have my a value is equal to 1, my b value is equal to 4, and my c value is equal to 3. So we get negative x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can sing the song if you want. Okay, so we get x equals negative b is -4 plus or minus the square root of 4 squared minus 4 times 1 times 3 all over 2 times 1. So x is equal to -4 plus or minus the square root of 16 minus 12 all over 2 times 1 is 2. Simplify the inside. Negative 4 plus or minus the square root of 4 over 2, which is negative 4 plus or minus square root of 4 is 2 all over 2. Now we're going to split these. So x can equal negative 4 plus 2 all over 2, and x can equal negative 4 minus 2 all over 2. So I get negative, I got to do the top first. Negative 4 plus 2 is negative 2 over 2, which is negative 1. Negative 4 minus 2 is negative 6 over 2, which is negative 3. Is that what we got? I did something wrong in zero product property. I see. In the big X, this should be a, since the 1 was positive, this should be a 1 right here, a positive 1. So when we use our zero product property, we're actually going to get a root of negative 1. So it should be x plus 3 times x plus 1. When I do my zero product property, we're going to get a root of negative 1. Okay? All right, last one. Completing the square. So I have my equation in vertex form. And when you have your equation in vertex form, you just replace y with 0. Okay, just like we would in factored form. And then we just solve. Because I can see I have a perfect square right here. So eventually I'm just going to be able to square root to get rid of the square. So I'm going to add 1. 1 is equal to x plus 2 squared. And then now I can square root to get rid of the square. Any copy of itself rooted is going to just give me x plus 2, so just itself. And then I'm going to subtract 2 from both sides, giving me x is equal to negative 1. Ooh, I see what I made a mistake on. You actually get 2 answers, plus or minus, when you take the square root. So I have to split this up. This is going to be, okay, 1 is equal to x plus 2, and negative 1 is equal to x plus 2 for my plus and my minus here. I'm going to go ahead and subtract 2 in each place here. I get x is equal to negative 1, and x is equal to negative 3, just like all the other ways we solved. Okay, so depending on what form you're in, there's advantages to finding the x-intercepts in different ways.